Let's talk about corn. It's used to fuel our bodies, power our cars, and make delicious bourbon. But today, we'll examine agricultural subsidies and their impact on domestic biofuel production. My name is Tim Hodson, and I'm an undergraduate senior in GIS at The Ohio State University. I'm interested in better understanding the relationship between agricultural land use and biofuel markets. Biofuels are fuels that are produced through biological processes like agriculture and anaerobic digestion, instead of the geological processes that form fossil fuels. They can be produced in a number of different ways, but the use of thermal, chemical, and biochemical conversion is needed. Bioethanol is alcohol-based and is made by fermentation. It can be used in its pure form, but it's most commonly used as a gasoline additive. There have been a massive increase in biofuel production and use over the last 20 years. With a growing concern over fossil fuel availability and environmental impact, markets are looking for new alternatives. But as with any new opportunity, there are also concerns. This presentation will attempt to examine the arguments made by different actors involved. At the center of the discussion is the use of subsidies. An agricultural subsidy is a government-funded program paid to farmers and agribusiness to supplement their income. It promises a set price paid to farmers in exchange for producing certain crops. It also allows the government to better control the production volume of given crops. There are parties for and against agricultural subsidies, each with their own motives. This analysis will look at four primary actors: farms and agribusiness, the corn ethanol industry, environmental scientists, and consumers. Small family-owned farms that might not otherwise be able to compete with large-scale agribusiness are able to survive and thrive, funded by federal subsidies. As agricultural intensification takes place, these small-scale farmers must invest more into equipment, seeds, and fertilizers. Even with these subsidies, many small farms are forced to sell as consolidation occurs. Large-scale agricultural producers are able to profit heavily due to economies of scale. This is seen in an expanse into corn syrup, animal feed, distillation, and biofuels. The corn ethanol industry plays a part in the causational relationship. They benefit from lower cost input as subsidized goods are cheaper and more available than unsubsidized goods. The more corn that is produced, the lower cost of their inputs. Waste products from biofuel production can be sold for cattle feed. Federal lobbying forces most gasoline production to include up to 10% ethanol. Those who are opposed to agricultural subsidies find issue with these claims. One of the primary reasons is that there is evidence that biofuels aren't necessarily a more sustainable approach to traditional petroleum products. The increased agricultural inputs necessary to grow the crops for biofuels negate the reduced carbon impact that biofuels promise to deliver. The Intergovernmental Panel on Climate Change wrote that biofuels have direct fuel cycle GHG emissions that are typically 30 to 90% lower than those for gasoline or diesel fuels. However, since for most biofuels indirect emissions, including land use change, can lead to greater total emissions than when using petroleum products, policy support needs to be considered on a case-to-case basis. Consumers are more aware of the impact their decisions can have on the environment, and they are being sold on the fact that biofuels are the magic answer. However, many biofuels are much more caustic than traditional petroleum products, and there is evidence that they are damaging fuel systems in cars, boats, and other types of equipment. This has led to the designation of recreational fuel that is purely petroleum-based without any added ethanol. In an effort to better understand the impact biofuel use has on production and consumption, we look to its life cycle. Biomass is first produced, typically corn, then shipped for storage and handling. The biomass then undergoes a processing and conversion process. The refined biofuel is mixed with petroleum products and distributed to customers. Consumers use the biofuel, creating CO2, which is ideally reabsorbed by the biomass production. As more agricultural producers shift to lucrative, subsidy-driven crops, a loss of biodiversity can occur. regional crop strains that have grown for years might be uprooted in favor of genetically modified strains that produce the most desirable products for biofuels. On the left, we see a graph illustrating the rise of ethanol production. On the right is a similar graph showing the increase in corn production over the last 100 years. As we compare the two, we better understand the supply and demand relationship that encompasses biofuel production. This graph does a good job at illustrating how corn is utilized within the US. While there was a sharp increase in ethanol use between 2003 and 2010, it seems to have stabilized. It's also interesting to examine how much corn is actually used to feed livestock and for residual use. Even with a large uptick in ethanol use, US farmers were able to meet the demand without too much trade-off. Government mandates require that ethanol be mixed into traditional gasoline for a more sustainable energy solution, which artificially inflates the demand for biofuels. As farmers benefit from growing biofuel inputs, the demand for these products increases, and thus do the crop prices. This revalorization has generated an entire industry and assisted in increasing the income across many agricultural producers in the United States. However, taxpayers can also indirectly feel the burden of subsidy-driven biofuels. It is their tax dollars that provide the subsidies required for biofuel production. This system is by nature anti-capitalist, as unprofitable industries are propped up due to federal mandates. The U.S. crop subsidies provide incentives for farmers to expand feedstock production, which benefits the biofuel producers by lowering input costs. This study develops a general equilibrium model to analyze the effects of a reduction in the U.S. crop subsidy on biofuel industries and social welfare. Biofuels have the potential to reduce the energy and greenhouse gas emission intensities associated with transportation, but can have other significant effects on society and the environment. Depending on demand, crop growing conditions, and technology, they may require significant increases in cropland and irrigation water use. Also, biofuels may have already affected world food prices. There are arguments for and against the use of biofuels and agricultural subsidies. The addition of federal subsidies to support the use of biofuels adds on a layer of complexity. Pro-subsidy farmers depend on federal help in order to make ends meet and continue competing with large-scale agribusiness. They also seek to reduce dependence on fossil fuels and shift to more renewable energy sources. But this shift does not come without trade-offs. Currently, biofuels don't produce much in terms of sustainability and prop up otherwise failing industries. Both sides provide compelling support for their claims, but ultimately one is forced to follow the money. In this review, we sought to better understand the relationship between agricultural subsidies and biofuel production and use, but there are still many questions remaining. To further benefit this study, one might seek to ask, who is benefiting the most from agricultural subsidies? Who is benefiting from the increased use of biofuels? Who is benefiting from keeping agricultural producers happy? These are questions that merit further exploration. Thank you.